assessment asks us to take the same alkyl halide and choose the reagents that would give either of these two alkenes. To start, let's look at the difference between the two alkenes. We'll notice that the one on the right would be considered, or the one on the top, would be considered an anti-Zaitsev product because we've made the less substituted alkene in this elimination reaction. Whereas the one on the bottom is tri-substituted, or the more substituted alkene, or the so-called Zaitsev product. Now, the other assumption we're going to make with this problem is because we have an alkyl halide at a secondary carbon next door to a tertiary carbon, we're going to assume that we want conditions that avoid rearrangement. If we made a carbocation at this position, it would migrate to this position, and we might get any number of alkenes. To avoid rearrangement, then, we're going to assume that we're under E2 conditions. And so that kind of recognition changes the problem. What base can we use that will do an E2 elimination to give the anti-Zaitsev product? For that, we'll want to use very bulky bases. So something like potassium T-butoxide as a very bulky base will give the anti-Zaitsev product. That kind of spoils the answer here. When we want to make the more substituted alkene, we still want to use an E2 base, so something that's strong. We'll keep it as an alkoxide, but instead we'll use ethoxide as our base. Sorry about where I've drawn it, but that is ethoxide. In fact, let me redraw it for you. We'll use ethoxide as our base to generate the more substituted alkene.